Alright, so in today's lesson we're going to be talking about how we can solve different types of polynomials. So notice this one we got to the fourth power, so we're going to try to factor it by getting everything to one side. And once we do that, we are going to factor out what they have in common. So notice we have a 3x squared in common, so we're going to factor that out, and we're left with x squared minus 16. So now notice that x squared minus 16 is a difference of squares. So we've talked about that a lot. Ignore that equal sign. I'll fix that in a minute. So x squared minus 16 factors to x plus 4 times x minus 4. At some point I realized the equal sign. Coronavirus is causing issues with my brain. Alright, there we go. Got that fixed. So now we just have to find what makes all these zeros. So we can say, well, 3x squared equals 0. Or just x squared. X plus 4 equals 0 and x minus 4 equals 0. So take the square root of 0, we get 0. Subtract 4 from both sides on that one, and we can, again, equal sign, coronavirus, destroy my brain cells. There we go. Now we can add 4 to both sides. So our solutions are 0, negative 4, and positive 4. Alright, so for our next example, we're going to refer back to something we did at the beginning of the semester called factor by grouping. So we're going to group the first two terms together and group the second two terms together. We also could have factored out a 2 out of everything if we wanted to at the beginning, but I did not. So notice the first two terms have a 2x squared in common, and then we have a 6 in common with the last two terms. So now we have that common binomial x minus 3 that we factor out, and then we're left with 2x squared plus 6. So now we have got that factored, so we're going to be able to set both of those binomials equal to 0. So we have x minus Alright, so we end up with x equals 3, and then here we got to subtract 6 from both sides, and then we're going to divide everything by 2. So we get x squared equals negative 3. So remember, when we take square root of a negative number, we're going to have an imaginary result. So we would have x equals positive negative I radical 3. Alright, so now we're going to do this problem here. So notice this follows the same pattern of like a trinomial. So we're going to factor just like that. We're going to split our x to the fourth into two pieces, x squared and x squared. Now we're just going to look for two numbers that multiply together to give us 2 and add up to be negative 3, which is negative 2 and negative 1. So now we can set both of those binomials equal to 0 and solve them. So we'd add 2 to the first one, and then we would take the square root of both sides and get x equals positive negative radical 2. So the next problem, we add 1 to both sides, and we take square root, and we get x equals positive negative radical 1, which is just 1. So we have positive negative 1. And we are done. Super easy. Alright, so now we're going to deal with some radicals here. So we want to try to get that radical by itself by adding x to both sides. And then I'm sure you're already thinking, hey, we're going to have to square both sides to get rid of that radical. So that's exactly what we are going to do. So remember, when you square x plus 2, that's really x plus 2 times x plus 2. So when we multiply that out using the box method or FOIL, we would have x squared plus 4x plus 4. So now we will just try to get everything equal to 0, try to get the equation equal to 0, and then hopefully factor it, or complete the square, or whatever method we choose. So we have an x squared plus 2x minus 3. Well, two numbers that multiply together to give us negative 3, but add up to be 2, positive 3, and negative 1. So we find two solutions here to be -3 and +1, because that's what makes them 0. And we should check them to make sure they work. So we plug in our -3 back to the original equation, and we plug in the 1 back to the original equation. And if you get a false statement, that means we have an extraneous solution. So we're going to take a minute and use your calculator, do it by hand, and see if both of these numbers actually work. Alright, so hopefully by this time you have double checked your work to make sure you get 2 out when you plug in -3 and 2 out when you plug in a 1. But -3 does not work, so that is considered an extraneous solution. Alright, so with this one we're going to get a little bit more challenging problem with radicals. So we don't want both of those radicals on one side. It's going to make it hard to multiply out. So we're going to move one of those radicals to the other side to make our life a little easier. So now, again, we're going to have to square both sides in order to get rid of that radical on the left. So we're actually going to have to use the box method or FOIL to multiply the right-hand side out. So I'm just going to use FOIL instead of drawing the box. So now we'll just go first times first, which would give us a 1. And then we would do outer, which would give us radical x plus 4. And we would do enter and get radical x plus 4 again. And then last times last is just x plus 4. Now we can combine our like terms, and we're going to get that radical by itself again. Because then we're going to square it again. Again, we got to make sure our solutions work when we get done, because we might be creating extraneous solutions by all the squaring we're doing. Alright, so I'm going to subtract x and subtract 5 from both sides, so we can just square that 2 radical x plus 4 to get rid of the square root. So now we're going to be able to square both sides. So we're going to have to multiply x plus 1 times x plus 1. So again, you can use the box method or FOIL for that. I feel like I'm writing so slow. So we have x squared plus 2x plus 1. And then on the right hand side we square 2 and get 4. And then when we square a square root, they're inverse operations, so we just have x plus 4. So we will have to distribute that through, and then we're going to get everything to one side, and you guessed it, factor. If we can't factor it, we should try using completing the square. Almost there though. We subtracted 4x, and then we're going to subtract 16 from both sides, so we end up with x squared minus 2x minus 15. So a nice easy factoring problem. We're just looking for two numbers that multiply together to give us -15, but add up to be -2. Well, that would be x minus 5 times x plus 3. Alright, so we get our answer of x equals 5 and x equals -3. But we do need to double check these to make sure they work, because we might have created an extraneous solution when we squared it. So we're going to double check them, plug in 5, plug in -3, and see which one, at least they both work. And you'll find that -3 does not work, and it runs off, but that is an extraneous solution, so we need to cross that off our list. Alright, so here's another fun but easy problem. So notice this one has rational exponents, so we're squaring it and then taking the cube root. So to undo that, we need to do the inverse. So we're going to cube it and take the square root of it. So we need to raise both sides to the 3/2 power. So we are left with x plus 1. And then, well, we can take the cube root of 4 and get 64, and then we take the raise the 3rd power and get 64, and then take the square root of it and get 8. So we've got to put our plus and minus in front of it. So now we can subtract 1 from both sides, And we have -1 plus 8 and -1 minus 8 are our solutions. Hopefully we plug them in and they both work. Alright, so this one we want to rationalize the denominator by multiplying everything by our common denominator of x times x minus 2. So I distribute that. Notice the x's will cancel out because they reduce to 1. So we'd have 2 times x minus 2. And then we distribute it up there. We would just have 3 times x because the x minus 2's were reduced to 1. And then there we'd have minus x times x minus 2. So now we need to distribute everything. We get 2x minus 4 equals 3x minus x squared plus 2x. So now let's get everything to the left-hand side. Let's get that x squared to be positive, so we're going to add that to both sides. Then we're going to subtract 5x because the 3x plus 2x is 5x. So now we end up with x squared minus 3x minus 4. So now we can factor this thing. Two numbers that multiply together give me -4, but add up to be -3 are -4 and +1. So our two solutions are x equals 4 and x equals -1. So make sure we don't have any issues like making our denominator 0, which we don't. Alright, so this problem, we're just going to solve it like we solve absolute values normally. Keep one the same, flip the signs of everything on the left hand side of the other one, and then we're just going to work them out. So I'm not going to talk my way through this. You can just watch it get worked out. So hopefully everybody's healthy and nobody's got coronavirus yet. So the assignment will be posted below this video. Have a good day.